So yeah, this is a Lenovo Mirage. It's actually it's got a chipset of a phone, and it records both fisheye feeds, and it combines them on the camera, so it's fully post-processed. You don't have to do anything.
What is the format for a movie?
It's a Google format, VR180. They've invented a new format, but they just shut down their Daydream project, so they may be shutting down this camera as well.
Okay.
I don't know what the future of it is, but it's a really lovely camera.
Is it expensive?
No, this is $90. Super cheap, but if they discontinue Daydream, then they'll probably discontinue the camera as well.
Yeah. Is it full HD or?
Yeah. I don't know how it works, but I'll try and put the footage in.
I guess it's some kind of power.
I guess you can drop it.
1, 2, 3. All right. Thank you guys for coming out and attending the session. What we're going to be doing today is going through the fundamentals of creating your first augmented reality application. This app is going to be built on top of Unity, the game engine Unity, and it's going to be built to target either iOS or Android. All the code is up on GitHub. It's open source. You can go check out the repo and try it out later. And the slides are going to be shared, so you don't need to take notes or anything. It's all going to be there, and the recordings as well. So what we're going to go through is getting your toolchain set up. We're not going to spend much time in PowerPoint, honestly. Go straight to my development machine. The basics of Unity. What is Unity? How do you use it and interact with it? What is AR Foundation, which is a layer on top of Unity that allows you to build applications that target both iOS and Android through one SDK. And then Q&A. So let me hop out of this here. So what I've got up here in front of on the screen here is the Unity editor. This is the free version that anybody can download and use. There's no special license required. They have an enterprise version as well, which if you want to ship anything, obviously you need to get that version. So this is a great free option just to learn the tool set. And there's another layer on top called the Unity Hub, which allows you to install and manage several versions of Unity simultaneously. Unity revs very quickly, so this is really crucial because there's always multiple versions coming out almost every week. And this allows you to have them all side by side and use the one that targets the project that you're working on. So I'm not gonna install it because it takes a long time, but I'm gonna show you the configuration that I have. I'm running Unity 2019.2.2 F1. That's a little bit out of date. There's a much newer build of 2019.2 that you can use, but the configuration is gonna be the same. Basically what you want is the Android build support with the SDK, NDK tools, and the OpenJDK. And when you install this, it'll basically put everything for you. So you don't need to go and install any other Android tooling if you don't want to. I sometimes put Android Studio because it's got a bunch of cool utilities if I'm working with Android. Of course, if you're working with Apple iOS, you need to work on a Mac. There's no good way to build for a Mac on a PC, for iOS on a PC. And that's really it. There's a bunch of other things I've installed, but they're not necessary. So once you've got Unity set up, like I said, that's all you need to do. And this will automatically put the entire Android toolchain, including ADB, into a weird location onto your file system. But there's documentation posted on how to find all the tools if you need them. But really, everything is done through the Unity editor, so you don't need to go outside this IDE too much. Let's take a look at the editor itself and see what are the basic components over here. This view over here is called the scene view. This is basically a hierarchy where you can, if you were building a virtual reality application or a game, all of the entities that you want to render on the screen would be present within your scene. Because we're building for augmented reality, it's a little bit different. Everything is dynamic. The content is created dynamically depending on what the context is. So, it needs to identify the floor and the walls, and then it can go to content here and there. So my scene is pretty much empty. There are a few entities in the scene, but I'm not going to cover them right now. We'll talk about what these things are later when we get into AR Foundation. But for now, the basic thing I want to explain is each of these objects in this kind of hierarchical tree is what's called as a Unity game object. And the key characteristics of a Unity game object are it's transformed. It's a position where this game object is supposed to show up. And then there's additional attributes you can put onto a game object that controls how it renders or if it renders anything to the user. So in this case, this game object is pretty simple. Let's look at a more complicated one. This is a canvas that allows you to draw two-dimensional user interfaces on the screen of your device, right? It's got some buttons in it. I'm not going to go into too much detail because it's a 30-minute session. We've got to kind of rush through. But this is all standard Unity stuff, right? Standard Unity UI. The main concept I wanted to get into here was this transform and the hierarchical nature of the Unity scene. So when you have something inside a scene hierarchy, right, the position and orientation and rotation of this object, the AR camera, is now relative to the parent object. And the parent object is relative to the world. So everything is nested. The other Unity construct that I want to talk about is mono-behaviors. So every single one of these game objects can have C# scripts attached to it, one or more C# scripts. And these C# scripts are called mono-behaviors. So for example, we've got a script over here called a mono-behavior. You can set up Visual Studio as the editor for Unity, or you can use VS Code or whatever you like. Visual Studio is probably the easiest because it comes bundled with Unity and it works reasonably well. But I just want to walk through kind of the anatomy of what do these C# scripts look like. They're all more or less the same. They all derive from the same base class, which is called mono-behavior over there. And the mono-behavior exposes three key functions that you should know about. One is awake and start. They're kind of related, but it's the initialization logic of your script. Then there's an update loop, which is called every single frame. So when you're writing code for Unity, you have to be cognizant of the fact that if you write something in the update loop, it could be called hundreds of times a second, depending on how fast your application is running. So you really have to, think about when you put something in the update loop versus somewhere else. So like I said, I don't have a start or an awake in my mono behavior because I don't have any initialization logic over there. I just have update logic, right? So the question you might be asking is, well, how are you just running a script without initializing anything? That's where the Unity editor comes in. Rather than set up everything in a constructor, you can have the Unity editor go ahead and kind of create the initial settings for your objects when you set them up. So for example, if you look at this script here, all of these fields that are showing up in the Unity editor are actually things that are exposed as serialized fields here in the C# script. So in order to have something exposed in the editor, you just need to mark it with this attribute. And that allows you to create scripts that you don't necessarily need to go into the code to be able to develop something like this. The next concept I'm going to show you in Unity is something called a prefab. So a prefab is basically taking a bunch of settings and baking that off into a file, a YAML file at the end of the day. So you can drag and drop this thing into your Unity scene, and it'll just replay all of the settings that you've set on that. So this Unity prefab has my nozzle script on it, and it's got two properties here, the cursor renderer and the trail renderer. And those are simply the properties that I marked here as serialized fields. That's why they're showing up over here. So because I've created this thing as a prefab, I can now just instantiate this thing at runtime, and I don't have to set up and wire up all these different relationships again. It's just a shortcut to be able to create complex objects. The next thing I'm going to talk about is textures and materials, which are kind of related. Textures are simply images. There's different options within Unity around how to compress these images, how to manage them, and it really depends on what you're using them for. Again, I'm not going to go too much into this. There's plenty of literature on how to use these. And the other thing I'm going to talk about is materials. A material it may either use a texture as a map in order to draw something on the screen, or it could just be a color material. But this is the way that you give the objects in your game color and texture by assigning a material to them. So in this case, I've got two simple materials, a dot material and a ring material, right? And they don't have any anything special about them. They're just normal Unity standard materials that use the Unity standard shader. So Unity does a lot of stuff out of the box for you. You don't have to do much to set up something like this. The goal with this application was to see what I could create within 30 minutes. So that's why it's very simplistic, but it also shows the power of the game engine. And this, of course, is the scene that I was talking about, the Unity scene. It's also saved as a file onto your file system. And you can switch between scenes in your application, and the scene is the basic unit of organization of all your code, all of your scene entities, all of your scripts. They all parent up to a scene at the end of the day. So this is a little bit of a clue of what this application is going to do. The scene is called Make Your Mark. Following the theme of VMworld, we've made a simple graffiti app. So the idea behind the app is it'll be able to find a surface, either a horizontal surface or a vertical surface, and then it'll mesh that surface. So it'll find feature points which are points of interest on the surface that it can identify again if it loses sight of them and comes back. And then it'll start to infer the spatial relationship between these points, and it can decide whether, these points are all coplanar, so this must be some kind of a wall. Maybe it's a vertical wall. And those points are coplanar, so that must be the floor. And that starts to get into the basics of augmented reality programming, right? The most basic unit is finding these feature points in the world. The next level of abstraction up is connecting these feature points into planes. And then what you can do once you've identified these planes is you can take your device and you can cast a ray from your device out into the world and see where it strikes a plane. And that's exactly what our app is going to do. When we register someone touching on the screen of the device, we're going to cast a ray from that point onto the nearest plane that it hits, and then we're just going to draw some graffiti on it from there. So what does that look like? All of that logic is kind of captured in this script over here. We also have a nozzle manager script that basically is just our UI business logic. I've added some simple buttons. Let me show you what that looks like actually. There's another view called the game view. So when you're running the game, it doesn't look like the user doesn't see the entire scene. They see this so-called game view. This is what the game camera is rendering on the screen. So I've added 3 simple buttons to this game view that just change the color of your graffiti. They clear all the graffiti off the screen if you want to restart your artwork, or you can change the size of your nozzle. And the nozzle manager is actually exposing some hooks that these buttons can call and cause the code to change. So for example, the size button, when you click on it, I don't know if you can, is that visible? Can you read what it says over there? There's an event hookup. So on click, it finds the nozzle manager, and it calls the script change size on the nozzle manager. You can also pass parameters, but in this case it just cycles through 3 different sizes. So let's do the nozzle manager first because it's really, really simple. It's also a mono behavior just like the other ones. But this script doesn't have an update loop because it is not required to do anything once per frame. In order to do this efficiently, everything is driven by events. So when you press the color button, this change color event will get fired, and then we can go and do something to the nozzle. This is a pattern that I like to use because in AR things are dynamic, so the object that you're trying to reference may not be created yet, and you don't want your code to just null out. So this is just a nice C# pattern of trying to get an object, return true if you find the object, return false if you don't find it, so that execution can continue without an error, and have an out parameter to instantiate if you do find the object. So all this code is doing is saying if there is a nozzle, right, go ahead and give me that nozzle so I can change its properties. Change color simply changes the color of the nozzle, and the way that works is by going into the material that I showed you earlier and changing a property of the material called the color. Similarly, changing the size of the nozzle goes to the nozzle itself and changes its transform scale. So remember how I said the transform is always hierarchical? So you have global properties of the transform, which is its world properties, and you have local properties, which is relative to the parent. So in this case, I'm changing the local scale of the nozzle and saying, relative to your parent, I want you to be twice as big or thrice as big as you were before. And that can scale it up or down. Clear just gets everything off the screen. And this is the little piece of logic that is trying to go and get the nozzle, right? So pretty straightforward little script. Let's look at the nozzle script itself. So the nozzle script has two parameters that get populated by the Unity prefab that I showed you earlier. There's the renderer, which is rendering the actual cursor that gets drawn on the surface that you're putting your graffiti on. So it's just a little white dot that allows you to see where's my graffiti gonna be drawn if I'm, like a cursor, essentially. And the other thing it has is what's called a trail renderer. So this is a high-level construct that Unity has created, which just draws a trail of particles. So you can imagine like motion trails. If you've got a character running, you want to have some lines coming out behind them. This is a nice little utility they've built to build that kind of a trail. And usually these trails expire over time, so they fade out and the trails stop persisting. But I've just set the properties on the trail to be persistent, so they never expire. And that's what allows you to kind of continue drawing and it doesn't evaporate. You could do all of this manually and do it yourself, but that's really the point of using Unity, is it has these higher level constructs that make things easier to work with. I like to use C# properties, so I've wrapped my internal variables in C# properties, but that's all it's doing over here. And this is where we get into the update loop. So what I'm doing here is I'm using Unity's platform agnostic layer to get touch information from where the user is touching the screen. And I'm basically asking Unity, where is the user touching the screen, right? So if the user is not touching the screen, right, then what I want to do is say, okay, when you first touch the screen, I want to start drawing the trail, right? So that's actually the else clause. Touchdown equals 0 means nobody's touching the screen, else somebody's touching the screen. So if somebody's touching the screen, I want the trail to start drawing. As soon as they lift their finger off, I want to detach that trail and save it off into the game world and detach it from the hierarchy of the nozzle, because I don't want the trail to move when the nozzle moves. So I changed the parenting so it's not attached to the nozzle anymore, and it just exists within the game world. And that's essentially what all this code up here is doing. It's just creating detaching the trail that I just created, as well as creating a new trail so that the next time the user touches the screen, I can start drawing that trail. So you can have multiple different, graffiti strokes to make an image and compose them together. I'm sorry for the speed. It's just, time is a little bit limited. So we'll have a Q&A section. We can go back through this in as much detail as you would like to. But let's talk a little bit about AR Foundation now, because that's really what enables us to do all of these high-level things. AR Foundation is another high-level construct or abstraction that Unity furnishes you that allows you to deal with things like feature points, planes, and the actual AR camera, which is, in this case, the phone. Your phone is the camera. Because in an augmented reality application, what happens is it turns on the camera on your phone, which is recording video from the real world, right? And then it's running computer vision on that feed to try and identify those feature points. So in order to do all of that stuff, it sounds really complicated. All you really need to do is create this AR session and this AR session origin. And these two objects manage all the state around being able to do all these computer vision things and surface all this information to the developer. And there's various components within here. The one that we're going to be looking at in more detail are the plane manager and the point cloud manager. So these two scripts basically are mono behaviors, just like the one that we wrote, but they're significantly more complicated. What these are doing are, whenever the computer vision system detects a feature point, this script, the point cloud manager, will intercept that event coming up from the computer vision system, and it'll allow you to draw something on the screen. So you can give the user feedback saying, okay, you've pointed the phone or the device at a surface that has enough features for me to start trying to figure out where the planes are. And the plane manager does the same thing. Once you have enough coplanar points, the computer vision system can determine this is a plane, and then the plane manager will basically display something to the user showing them this is the extents of the plane that I've been able to figure out. And again, AR is very dynamic. So you may identify, so this floor, for example, the first time you point the phone at it, it may identify just 2 square feet as being a plane, but it'll keep updating that plane as it figures out how large it is. So there's constantly events coming from this underlying system saying, oh, the plane is now 1 meter by 2 meters, the plane is now 3 meters by 4 meters, and until it finds the edge of space. Then let's talk about the AR camera. So the AR camera represents your phone in this case. And the way this works is there's this script over here called the track pose driver. This is again published by Unity, not something you need to write, and it's well documented. But the general idea here is it's using the phone's camera, the phone's IMU, the feature points that is detected to figure out the position of your handset in 3D space. And the reason it needs to do that is so that as you move your phone around the scene, the content stays locked where it's supposed to be and doesn't drift around. So that's what the AR camera is doing. And the AR camera is a child of what's called the AR session origin. And the reason for that is the session origin creates a kind of persistent space in which you can create fixed objects. For example, you could drop a cube into the session origin, and it would always float there. So as you move the camera around the cube, it'll always remain in a fixed position. We're not doing anything like that because we're using the planes to draw our content. We don't just arbitrarily create content. And the way we do that is with this script called place on the plane, which does exactly what it sounds like it does. It basically casts a ray out from the device, and then if the device hits one of those identified planes, it will go ahead and give you the position of that hit, that raycast hit. And then it's up to you as a developer what you want to do with that information. In this case, what I've told the script to do is take the prefab that I've given you, that nozzle prefab that I showed you way back in the beginning, and stick that nozzle prefab on the point where the plane is, where the ray intersects the plane. And that's what keeps your cursor kind of stuck to the plane that gets detected. So let me show you really quickly what the app looks like. Unfortunately, my USB-C port is used for the monitor, so I can't connect these two together. But I'll just hold it up like this particularly. And of course, you can download the source code and try this out for yourself. So what's happening here is you can kind of see the cursor over there, and looks like there aren't any interesting feature points here. Oh, here we go. The floor is great. So I don't know if you can see it, but those dots that are on my screen are being drawn by the AR plane manager. And what's happening here is because it's detected a plane, I can drag my cursor around on the floor, and I can kind of walk around this thing from different angles, and it'll stay put, stay where it's supposed to be. I can also change the size of my cursor, change the color, say I want to do some red, and it'll just draw on top of it. I can clear all the graffiti off and get rid of it. So that's essentially all the application does, and there wasn't much code required to make it do that. But what's actually happening under the hood is quite complicated and quite tricky. I want to end it here and kind of give you guys, and I just dumped a bunch of information on you. So instead of me going on anymore, I'd like to stop and let you guys ask any questions. Is there anything you want to go into more detail on? Anything that was kind of confusing, or what would you like to know more about?
How complex does the surface recognition get?
Pardon?
How complex does the surface recognition get? If you put it in a bunch of those spaces.
Sure. So the question was, how complex does the surface recognition get, right? AR Foundation has surface detection, face detection, skeletal detection, so you can point it at a person and it will give you a rough outline of their skeletal positions and joints. And they're building more stuff every day. 3D object detection is coming pretty soon, so you can specify an object by capturing images of it from various angles, and then if it sees that same object again, it will identify it, let you know, and you can annotate it with some content. So it's getting more sophisticated every day.
Would it be much harder to make it into an app where you look through glasses and use your hands to interact?
The idea behind AR Foundation is that it is cross-platform, so they do not support head-mounted displays today, but that's on their roadmap for the end of the year. So by sometime before December, we will be able to take the same application and basically just say, push it to a HoloLens, and it should just work. There's some nuances because what I'm doing here is I'm using the user's position of their finger on the device screen to cast the ray. I would need to change just that code to say instead of using the position of the finger on the screen, use the position of the user's hand in 3D space to cast the ray. So you could kind of draw with your finger like this. So there would be some changes required, but it's mostly around the interactions. And that's actually a great question. You might be wondering to yourself, why am I up here presenting this at VMworld? Well, one of the products that we announced this VMworld is an augmented and mixed reality SDK that we're publishing that will allow you to do interaction across modalities. So our opinion is that virtual reality and augmented reality are really two flavors of a very similar thing. And so we're trying to create a device-agnostic cross-platform interaction system and SDK that will allow you to build applications that gracefully fall back. So if there's hands, you can interact with your hands. If there's no hands in their controller, you can use that. If it's only gaze, you can use that. If you want to use voice, you can use that. And we have a booth over on the expo floor if you want to come out and see some of the stuff that we've put together on top of our SDK. Cool. Great, thank you very much. Again, sorry for railroading through that. It's so in the main VMware booth, there's a
Right down there,
yes,
all the way to the end. You find the VMware booth, and it's on the first one on the left. Really great piece to kind of like not too complicated, but where it can go. Thank you very much. There are the other options, of course, web, there are different tools around working with WebGL. WebGL is just starting to introduce virtual reality They want to do this in the browser. Same stuff that is necessary. So just go to the website and you browse. Thank you.